Alright, let's do another example using the quotient rule. Find all horizontal tangent line to the graph x squared minus 2x over e to the x plus y. So let's try this. Solution. Okay, what is the slope of a horizontal line? Slope of the horizontal line is not the tangent line. Just let's get rid of this for a moment. What's the slope of a horizontal line? Any horizontal line? Zero. A horizontal line doesn't have any rise, so when you use the slope equal to rise over run, you only have run. Rise is 0. 0 over run is 0. Okay, so horizontal lines have zero slope. Okay, and what's the slope of a tangent line? Derivative, right? So what is this question trying to say? It's trying to ask when this derivative is equal to 0. So for what x values does this have the derivative equal to 0? If the derivative is equal to 0, then you can use that x value to plug it back in, and then you can locate the horizontal tangent line. Okay. All right. So we will have to differentiate y. And the way you differentiate, because this is a quotient, you have to use the quotient rule, which says high d, so x squared minus 2x prime times low minus low d times high over e to the x, the low squared. Okay. Then we get 2x, x squared differentiates to 2x, x differentiates to 1, and e to the x prime is just e to the x squared minus 2x, and you have e to the x squared. Okay. Now you can combine these two because, you can factor e to the x out, right? So if you factor the e to the x, from the first one you have 2x minus 2 left. From the second one you have minus x squared plus 2x left. Okay. Over e to the x squared. Okay. Now because this is e to the x times e to the x, one of the e to the x can be used to cancel this. Right? So that can be canceled. And if I simplify this, I get negative x squared plus 4x minus 2 over e to the x. Okay. And what are we looking for again? We're looking for when this is equal to 0. Okay. Unfortunately for us, the numbers are kind of horrible. But see, if you have a fraction, the only way a fraction could be 0 is when the numerator is equal to 0. So we're really looking at when negative x squared plus 4x minus 2 is equal to 0. That's what we're looking for. And I don't like minuses in front, so let me just multiply negative 1 everywhere. So it becomes x squared minus 4x plus 2 equal to 0. You don't have to, but I like to. Okay? And now you can use the quadratic formula. Negative b, 4 plus minus, square root of 4 squared, which is 16, minus 4 times 2, over 2 times 1. My pre-calculus students told me that there's a song for this one too. The only thing I remember is all over 2a, something like that. Okay, but if you have 4 plus minus square root of 8 over 2, this is 2 radical 2, so if you can simplify this to be 2 plus minus radical 2. So you actually have two places where it has a horizontal tangent line. So those are the values where you have the horizontal tangent line. You know, I kind of don't like the numbers, so let me just change the question. Sometimes if you don't like the answer, we can just change the question. You have a question?
Yeah, for part 1 where you see y prime equals that, why did you differentiate the first half but not the second half? You see you brought down 2x minus 2 e to the x minus e to the x, x squared minus 2x.
Oh, what's the derivative of e to the x?
E to the x.
E to the x, so I did differentiate.
Okay.
All right, so let me change the question. Find all x values where there is a horizontal tangent line to the graph of this. Okay, so after I put that in there, that's where I can stop, right? If I wanted to solve the original one, then not only I have to get the x value there, I have to plug that back into the function to get the y value, and only then I can come up with the equation. So I didn't like it. So let's stop here.